So in this particular session, I'm going to give you a problem, and my discussion is, as you know, it is about F-test. So I'm going to give you a very simple problem. Just now I discussed about how to deal with such a problem using statistical software, but here is a problem which can be done without using the statistical software. So the question goes like this: two random samples gave the following results. Okay, the results are as follows. We have two samples, sample 1 and sample 2. The size of the sample 1 is given to be 10. The size of the sample 2 is given to be 12. Sample mean is given to be 15, which you know it is x1 bar, and sample mean of the sample 2 is 14, which is x2 bar, and sum of the squares of the deviation, sum of the square of the deviation from mean, it is given as 90, which is not S1 square, remember, and the second one is 108. So what is this? This quantity is actually summation xi minus x bar whole square. This quantity is given over here for the first sample, and the second sample, the quantity is given to be summation yj minus y bar whole square. And we need to test whether the samples come from the same normal population. At 5% level of significance, okay, and some tabulated values are given. In the question, the tabulated values are given as the following. At 5% level of significance for 9, 11 degree of freedom, the tabulated value is 2.90. For 5% level of significance, the tabulated value for 11 and 9 is 3.10. The tabulated value of t at 5% level of significance for 20 degrees of freedom is 2.086, and the tabulated value of t at 5% level of significance for 22 degree of freedom is 2.07. Now we actually do not need these 4 tabulated values. We need any of these 2 tabulated value. Any one will work over here, and here also we do not need the 2 tabulated value. Any one is needed. We just have to find out which one is the appropriate tabulated value that will work over here. And this question is similar to the question earlier discussed. It is simpler than the previous one, because here the individual data points are not given. What we need to do is to just feed the particular data into the formula, and we have to find out our observation. Okay, so we can do it in the following manner, that for the 2 samples to come from the same normal population, one must have population mean mu1 or population mean mu x and population mean mu y must be same, as well as population variance sigma x square and population variance sigma y square must be same. And we can associate a random variable x to this data, and we can associate a random variable y to this data. We will set up our null hypothesis as follows, that mu x equal to mu y, and alternative hypothesis as follows, which is mu x is not equal to mu y. And since the sample size is small, sample size here is 10 plus 12, which is 22. Total sample size is 22, which is less than 30. So to test this, we can apply the t-test of difference of mean. And since we are going to consider two null hypotheses at a time, so we can change the symbol to this H01 and H11. Our formula for this case will be, let me write in the next page, under H01, my formula for t-test will be as follows. So it will be t is equal to x1 bar minus x2 bar. Actually, the t formula, t statistic is given to be x1 bar minus x2 bar minus mu1 minus mu2, but this part will not be there, and blah blah blah. This part will vanish because we have assumed that mu1 equals to mu2. So under H0, this will be equal to 1 by s square. Probably in this previous session, I wrote it as capital S, but if I've done so, it is wrong. It should be s square, and this is the formula that I'm going to use. It follows t distribution with n1 plus n2 minus 2 degrees of freedom. And since my n1 is 10 and my n2 is 12, so this implies n1 plus n2 minus 2. This will be equal to 22 minus 2, that is 20 degree of freedom. And immediately we understood that actually we need this tabulated value, and that tabulated value is not required. Then we will try to feed the data into it. X1 bar is 15 and X2 bar is 14. And for calculation of capital S square, we need to apply this formula, that is 1 by n1 plus n2 minus 2, which is summation x1 minus x1 bar. You can consider this xi minus x1 bar, sorry, over I whole square, and this is summation yj minus y, or y, you can consider this to be x2, okay, xj, consider this to be xj minus x2 bar over j whole square, and this is the formula. And if I apply, and here you are going to write it as 1 by 20, of course, and this part will be 90 plus 108 because this is given in the chart, and it is coming as 9.9. Now we are going to apply this value of s square over here, 9.9, and the sample sizes reciprocal will be taken like this. And if I calculate this particular figure, then the value that is coming is as follows. And from the tabulated value, we find that comparison with tabulated value gives us that calculated modulus of t is less than the tabulated t at 5% level of significance at 20 degree of freedom, and this implies H0 1 mu x is equal to mu 1 mu y is accepted. Now let us discuss the second part. In the second part, we have to consider the null hypothesis as follows. H02 is sigma 1 square is equal to sigma 2 square, and H1 square 2 is sigma 1 square not equal to sigma 2 square. Under H0, your statistic f will be S1 square by S2 square, depends upon the fact whether S1 square is greater than S2 square or not, and this will be S2 square by S1 square depend on the fact whether S2 square is greater than S1 square or not. And then you have to calculate the thing. Your S1 square means N1 minus 1 summation xi minus x bar whole square. So if I do this calculation, we'll get 90 minus 10 minus 1, which is 10. And your S2 square is 1 by N2 minus 1 summation over j yj minus y bar whole square, which is 108 by 12 minus 1, which is 9.82. And we find that S1 square is greater than S2 square. And therefore, we are going to apply the following formula. Not this one. This one will not be applied. But in the software that we have discussed a few minutes ago, doesn't matter whether you write it as I calculated variance of x by variance of y. Software program automatically takes the bigger one on the numerator and the smaller one in the denominator. And if I put it wrongly in the software, in the program algorithm just compare the two things separately, and it takes the if they take the ratio of the variance, they consider its reciprocal if needed. Now, when I apply this formula, that I get f to be 10 by 9.82, which is coming out as 1.018. And we know that this f actually follows f distribution with n1 minus 1 and n2 minus 1 degree of freedom. So here in case of f, the degree of freedom, here I'm writing, in case of f test, the degree of freedom here in this case will be 10 minus 1 and 12 minus 1. That is 9, 11. And immediately after this observation, we have understood immediately that we need this tabulated value for the comparison, and this value is not needed. So if I compare the value, what we obtain is the following, that we find that calculated f is actually less than, it is 2.90. So calculated f is actually less than the tabulated f at 911 degree of freedom. Sorry, it's not coming. Okay, 911 degree of freedom, and therefore H01, H02, which is sigma x square is equal to sigma y square. This is accepted. So here in this case, from we see that both the null hypotheses are getting accepted, and our final conclusion will be written in the following manner. Final conclusion: that since in case 1, H01 mu x equal to mu y is accepted, and in case 2 h11 sigma x square and sigma y square is accepted. So together they imply that the two samples have come from same normal population. I have intentionally taken the pain to calculate the entire thing to show you that how this problem is done. And you may think that in the previous session, I already told you about this particular type of problem using the software, but not every student is having the software with them. So I think it's important to let them know how to do this calculation manually. But it will take this calculation have been done. This has been done manually because the data were already this data, they were already been calculated. But if suppose instead of giving you this data of sample means, they give you the sample, then it is a matter of time to calculate the thing, and then you come to your conclusion accordingly. So it will take some time. Apart from testing the variance ratio, F test can also do similar kind of thing. So there is another application of F test, which is as follows. F test can also be applied for testing the significance of an observed multiple correlation coefficient. Multiple correlation coefficient. Now, this is a kind of a thing which has not been discussed in the classroom. We know that if there is a correlation coefficient, we can test the validity of the correlation coefficient using T statistic, but that is about the single correlation coefficient that I discussed about. But in case you are going to have data regarding the multiple correlation, then you cannot use the T test. Multiple correlation is something where you actually need to consider not bivariate distribution, but rather than a distribution which is having more than two variables. Multiple correlation coefficient is actually having a different sort of formula. So I think a brief discussion on multiple correlation is actually will be helpful in this regard. Suppose we are considering a trivariate distribution. For example, trivariate means variable consisting of three observations, a distribution consisting of three random variables, x1, x2, x3. And suppose that in each of these cases, there are small n observations. So number of observations are same for each of these three variables. All of these three variables have same number of observations. Then if it is so, then the multiple correlation coefficient between multiple correlation coefficient, sorry, this line is not, multiple correlation coefficient of the variable x1 on x2 and x3, on x2 and x3 is denoted by capital R1 dot 23. The effect of x1 on the two variables x2 and x3. So this is the notation that we actually use, is the simple correlation coefficient, between x1 and the joint effect of x2 and x3 on x1. And this multiple correlation in case of R1.23 square, this formula is given to be R12 square plus R13 square minus 2R12 R13 R23 divided by 1 minus R23 square, where Rmn is the Carl Pearson's correlation coefficient that we have studied already between m and n. And similarly, you can also try to find out from the above this particular expression what will be the corresponding formula for other type of multiple correlation. Say for example, here I'm giving it for you. Try to find a similar formula for the following case. For the following cases. What are the cases? You can consider this also, and you can consider this also. So in this way, the multiple correlation coefficient can be calculated. And if we have the observed multiple correlation coefficient in case of some random samples, then that can be tested. Their validity can be tested with respect to some population with the help of F-test. But I am not going to the details of F-test of checking the multiple correlation part over here. It is actually beyond the scope of the syllabus. But multiple correlation coefficient is the kind of thing which is actually belonging to the chapter called it is actually belonging to the chapter of multiple correlation and multiple regression. It is actually dependent. It is a multivariable case, and multivariable case is beyond the discussion of multivariable case is actually beyond the scope of our syllabus. So I'm not going into the details. Just since I wanted to tell you that F-test has various other applications, but only one application that have been introduced in your syllabus. Likewise, for multiple correlation, just like multiple correlation, there is another correlation which is called partial correlation. I'm not going to tell you what it is, but here also for trivariate distribution, you can also define a different type of correlation, which is called partial correlation. I have not seen any such question on multiple correlation and partial correlation in previous question papers. So if you find any sort of any type of these questions in the previous question paper, you can immediately knock me, then I can help you out in this regard. Otherwise, I'm not going to talk about these things, these issues over here. Before I end my today's session, I must tell you that I must again tell you that since I do not, most of the students do not have the access of a statistical software. So again and again, I'm saying that the easiest way of having a statistical software of finding a statistical software is in your Microsoft Excel. Try to discover your Microsoft Excel from the viewpoint of statistical calculation. You have already known that chi-square testing can be done by Microsoft Excel, then t-test can be done by Microsoft Excel. Try to find out whether you can solve f-test for analysis of variance is a kind of thing which is studied in statistics. Analysis of variance is where we actually study the equality of several means, not just two means. And here the f variance ratio is used. Your Excel can calculate the thing called analysis of variance. Analysis of variance key is there in Excel, but separately where f test is there or not, I don't know. I do not have any idea, or I didn't check it. Okay, so try to find out whether this is your homework for the weekend. Try to find out whether Excel can solve f variance ratio or not. Okay. So with this, I can say that I can stop the discussion of the topics of Unit 6 of your syllabus. Nothing more is left as such, apparently, in this particular Unit 6. Okay, and next week, I'm going to talk about the bivariate distribution, which is the part of, I think, so far as I can remember, it was the topic contained in Unit 3. Which I left for discussions, and intentionally, because that is too mathematical, and I wanted to discuss hypothesis testing, which is more practical before that. Now, with the discussion of bivariate distribution, we are going to conclude the discussion of this BSM 201 syllabus. Okay. And by tomorrow or day after tomorrow, I'm going to send you one Google form where you are going to give your course exit feedback. Course exit feedback is not my feedback. You are not going to talk about the teacher, because you see that if I take my own feedback, that can be manipulated. Nobody is going to believe me. Even if I don't manipulate, nobody is going to believe me that I have not manipulated. This is the people's psychological mind. And because of this, another branch of statistics have been opened, which is called psychological statistics. Anyways, so I'm not going to take my personal feedback, but I'm going to take the subject feedback. There will be not many questions, only 4 questions will be there. We have to just fill this form, and it is for the record of document. It is just for our purpose of documenting things. For different types of accreditation process, we need to show those, need to produce this documentation. So I'm going to share this Google form soon, and you are going to fill it up. Okay, so with this, I'm going to conclude my today's session. And before I end my today's session, okay, I'm stopping the record now. Record button is not needed. Just a minute.